Hello, learners, and welcome back to our Calculus Primer series, where we are diving into some topics that are necessary for your success in AP Calculus, or maybe a calculus course that you're taking at the college level. So what we're going to do in this video is talk about properties of exponents. And I know this is something that is introduced in your first year in an algebra course. However, it is, in my experience, a topic that a lot of students struggle with, so I'm here to provide some assistance. Now, on the right-hand side of the screen, I have listed a few of the very important properties. This is not an exhaustive list, but it is a pretty good one that just kind of runs through a lot of the important properties. So, for example, the first property you see, if I have two real numbers that are the same base, so let's say it's like 2 and 2, their exponents can be added together if those two terms are being multiplied together. If these two terms are being divided, or there's a quotient of two terms, as long as those bases are the same, we can subtract the exponents. Any number to the 0th power is 1. That's always true. X to the -1 power is basically the reciprocal of 1 over x. So what I did in the next property is showed you, well, what if you have a negative on the bottom? Well, if I have 1 over x to the -1, it's the same thing as 1 over x. And then you can flip that and you get x, or you could just kind of there's a lot of different methods for dividing fractions. The ear method, my calculus teacher in high school taught me, is like a soccer ball method, like I don't know, it's really weird. But I think flip is something that a lot of students do enjoy. And then finally, if I have a term raised to some exponent, and if that term already has an exponent, then what we do is we just multiply those two numbers together. Okay, so without further ado, let's kind of go through these problems. So in number 1, I have x. Both of these terms have an x. So what I can do is I can add those. So -2 plus -3 is -5. And then I have x to the -5 to the 4th power. So I'm going to multiply those two numbers, and I get x to the -20. Okay. Now, if we read the instructions, which we should have done before we started, so that's my bad, and I do apologize, is to simplify, and then your answer should only contain positive exponents. So we are close, but we do not have a positive exponent. To make it a positive exponent, we're going to do the reciprocal of this, and we would get 1 over x to the 20th power. Okay, and that's it. For number 3, let's kind of tackle this in two separate ways. Let's do n to the 3rd raised to the 3rd power, which would be n to the 9th, times 2, and then I have n to the -1, so that n does end up on the bottom. If we combine these, we will get 2n to the 9th power over n. And then I have n to the 9th over n to the 1st, so 9 minus 1. And just so you know, yes, there is a 1 right there. 9 minus 1 will get us 8. All right, number 5. It looks daunting, but just stick with me. We will get through this fine. What I like to do here first is just look at the coefficients, or the numbers in front of our variables. And so I see I have a 2, a 4, and a 3, and in the denominator I have a 3, so I can actually cancel those two 3s out, and I know I'll end up with an 8. Okay. Now all the terms on the top are being multiplied to each other, so my x's, I'm going to combine those, and I would get x squared times x squared times x, which would be x to the 5th. And then I have y to the 4th times y to the 4th, which would get me y to the 8th power, all over x to the -3, y squared. All right. So I still have the 8. That's not going anywhere, although you could write it as 2 cubed if you would like, be my guest, but I will refrain. I have x to the 5th over x to the -3. So 5 minus -3 is going to give me 8. So I'm going to have x to the 8th. And then I have y to the 8th minus y squared, or sorry, y to the 8th divided by y squared. So I could do y to the 8th minus 2, which would be 6. So that's the result of simplifying that. Okay. All right, let's come down here to number 9. So the numerator x is unchanged. The denominator, however, I have 2x to the 0 power. And anything to the 0 power, whether it's a variable or a real number, and I mean a variable can represent a real number, so it does follow the same rules. X to the 0 is 1, so I have 2 times 1, which is 2, all squared, and I will end up with x over 4. Now, a mistake that I could anticipate students making is students thinking that this whole term, the 2x to the 0, is actually 2x all raised to the 0th power, which is not true. The 0 here in the exponent only is attached to the x. It is not attached to 2x. Okay. All right, let's take a look here. So 2m to the negative 4 all over, well, I do have this cubed here. 2 cubed would be 8. M to the negative 4th times 3, that would be negative 12. All right. 2/8 will reduce to 1/4. You don't need to write the 1 up top. I'll get rid of it here in a moment. And then I have, as you can see, hopefully, m to the negative 4 over m to the negative 12. So negative 4 minus negative 12 will result as negative 4 plus 12, which would give me m to the 8th power. So as a matter of fact, I could write this as m to the 8th over 4. And don't try to do anything after that. Okay, moving forward, number 13. This is a great one. The reason why I wanted to do this is so you could see that I have a to the negative 3, b to the negative 3. Those cannot be combined because they are two different bases. However, that whole expression is raised to the 0th power. So this will just be 1. And that's it. In number 15, let's go ahead and, how do I want to do this? Well, let's just get started and see where my process takes me. So I have 2 to the negative 3rd, b to the negative 3rd, and then a to the negative 12. So 2 to the negative 3rd is 1 over 2/3. A is going to be 4 plus a negative 12, which is a negative 8. And then b is 1 plus a negative 3, which is negative 2. Okay. So it looks like, as a matter of fact, there will be nothing in the numerator except for a 1. And then 2 cubed is 8. And then we can throw the a to the negative 8 in the denominator. And then I have b squared. And that's as far as I want to simplify that. And that's good. All right. And that's kind of the nice thing too in the AP Calculus exams traditionally, if you haven't really messed up your calculus, if you mess up your algebra, you may not get full points, but you will at least get points for doing correct calculus, which is always positive. And then the last one I would like to do is this beast right here. And I will start off similar to how I started off the previous problem. So 2 to the negative 4, p to the negative 4, m to the positive 4, and then q to the 0 is 1, 1 to the negative 4 is 1. So I don't need to write that. Times 2, m to the negative 1, p cubed, all over 2pq squared. Well, I have a 2 here and a 2 here, so those will cancel. 2 to the negative 4 is 1 over 2/4. My p, so up top, I have negative 4 plus 3, so that's negative 1. And if I have a negative 1 up top and a positive 1 on the bottom, negative 1 minus 1 would get us negative 2. So I would have p to the negative 2. And then m is the only thing, let me just make sure that nothing here is, okay, we're good. M to the 4th times m to the negative 1 is going to get us m cubed. So m cubed will stay up top. And then 2 to the 4th is 16. And then this becomes p squared. And then we cannot do anything past this point, okay? All right, so as always, if you have any questions, please leave them in the comments below. And if you are one of my actual students, then you can ask me those questions in Canvas or through Remind. All right, happy learning, and thanks for tuning in.